Dear fellow colleagues, I plan to say a few words about information ontological model of Helianthus cultivation in Ukrainian conditions. This result was done with my colleagues Elina Tereschenko and our experts Kateryna Vedmedeva and our PhD student Stanyslav Vedmedev. Our experts from the Institute of Oilseed Crops of the National Academy of Agricultural Sciences were involved in the work. The paper presents a subject ontology which focused on agricultural technology for growing sunflowers in Ukraine. The experts identified objectives and influencing factors on sunflower yield and formulated issues of ontology competence. The results of the work include the substantiation of the need to create an ontology of sunflower cultivation in Ukraine and its integration into the pan-European community. Based on the results of ontology modeling, it is recommended to use an ontological approach to manage the created data repositories on sunflower cultivation, its selection, genetics, and phenotyping. The ontology was built in the Protégé editor. Sunflower culture is among the most important and economically profitable in the world, Europe and Ukraine. This is confirmed by the creation of the International Sunflower Association. The goal of this association is to develop research and strengthen natural cooperation at the agronomic, technical, and legal levels. Ontologies serve as a common standard for the semantic integration of a large body of plant genomic, phenomic, and genetic data. For example, phenotype and trait ontology and sunflower ontology is a crop ontology part with number 359 contains 351 records of sunflower phenotypes, but is foreign information. Accessibility for review and the opportunity to present the research results allows using the already known necessary requirements for the method of storing information. Our work is devoted to the actual topic of building an ontology of sunflower cultivation and its integration into international information resources. The purpose of the study is to build an ontological model of sunflower cultivation with a focus on the agriculture technology of sunflower cultivation in Ukraine, and to analyze the need of creating such an ontology and its integration into the world agro-ontology system. The environment of experts is a priority compared to the automatic method of ontology construction. The experts of the Institute of Oilseed Crops of the National Academy of Agricultural Sciences identified objectives and influencing factors on the figure 1. The sunflower yield productivity is affected by a system of factors for the year, for the growing season, and the distribution of factors over the growing season and calendar year, as well as the quality of the sunflower plant, genotype, variety hybrid, and adaptability to environmental conditions. In addition, the yield is also affected by soil conditions, climatic conditions, disease, pests, technologies, and timely control of factors. Based on the information provided by the experts of the Institute of Oils, at the first step, the subject area of knowledge about sunflower, soil fertilizers, and weather conditions, irrigation technologies, and other agriculture technologies was determined, and the terminological concepts provided by the experts were defined. Fragment which you can see on the table 1. Standard and catalogs of fertilizers, pesticides, herbicides, and technologies were also used. At the second step of ontology, building based on the information determined at the previous step, structures let the providers a unified interpretation of terminology by all participants in working with the ontology, namely experts, developers, and users. At this stage, the main classes and subclasses of the ontology were determined on the basis of factors affecting the harvest, such soil, climatic conditions, and laboratory research. On the next slide, we can see ontological graph in this Helianthus ontology. At the next stage, the model of the subject ontology Helianthus was built in the Protégé editor and represented in the figure 2. To determine the 3 root classes of the ontology, the expert statement on the main directions of research on sunflower culture at the Institute of Oilseed, namely agriculture technology, breeding or selections, and genetics, was used. The basic concepts of these directions form subclasses that form the third level of the hierarchy, which correspond to certain types of class diversity. For example, the class soil contains 3 subclasses: mechanical composition, chemical composition, and living component of the soil. In turn, the classes of the lowest level of the hierarchy have a corresponding set of instances. For example, for the classes mechanical composition of the soil, instances are considered sand, clay, and humus. All classes are disjoint, which follows from the definitions of the basic terms. The experts emphasized the need for such a factor as a timely implementation of agritechnological processes. It is important to note that the definition of on time can take place according to different indicators, namely soil temperature, soil activity level, start of vegetation, the prevention of pests and disease, and the total amount of precipitation for a certain period. Therefore, we introduce the time class into the ontology, which has subclasses related to the main issues of growing practitioners, farmers, who seek advice from the institutes, employees from different regions of Ukraine. The example of presenting the main result of ontology development is shown in figure 3. The ontologies are created for further used in decision support systems and should allow to contain nested and form new knowledge that meets the needs of users. To ensure semantic content between the components of the ontology, the corresponding relationships are set partially shown in table 2. Next slide. We have two types of ontology: quality evaluation and reliability assessment. Semantic evaluation is based on competence questions formulated by an expert, and structural evaluation is quantitative metrics of the ontography. The assessment of the semantic quality of the ontology was carried out with experts, as a result of which many competency-based questions were formulated. The first column of table 2 gives an informal expert representation of the questions. The second column gives a formal representation using ontology class names and using first-order predicate logic. And the last column lists the relationships between classes and queries. On the next slide, we can see continue table 2, which consider competence questions in informal form. The presented results of the formalization of competency issues were studied and confirmed by experts in this field. And now we consider structural evaluation. To perform a structural evaluation of the constructed Helianthus ontology, we compare its structural estimates with the average and median values for existing all ontologies according to the source, and the same structural estimates for the sunflower ontology with number 359 in table 3. The sunflower ontology includes 273 classes and 81 classes in the Helianthus ontology, with an average value of 36 and a median of 6. The number of first-level superclasses are 8 and 3, respectively, with the median value of 5 and the average of 6 for existing all ontologies. The number of individual object properties are 353 and 36. And 36 respectively, with the median value of 6 and the average of 28 for existing all ontologies. The ontology schema deepness is a measure of reliability and is calculated as the ratio of the number of subclasses to the total number of classes. Depth of the 98 for sunflower and 96 for Helianthus characterize ontologies as deep. Therefore, metric estimates confirm the reliability of the proposed ontology. Summarizing the results of the analysis of the received evaluations, we emphasize that the proposed ontology is in the development stage and certain classes will be filled when working with experts. And our conclusion, the scientific is the creation of an ontological model of the subject range of sunflower cultivation in Ukraine. The experience of national experts in breeding, genetics, and agriculture technology of sunflower cultivation, as well as the state standards of Ukraine, were taken into account. The ontological model allows further integration of national resources and knowledge bases in this area, as well as the development of a unified presentation of the results of scientific research and experiments. The practical value lies in expanding the possibilities of collecting experimental data, extracting new knowledge, promptly consulting practitioners, and integrating into the global scientific community. All this implies the evolution of ontology, in particular, in connection with the emergence of new varieties and hybrids with phenotyping. In the course of the study, it was found that the presentation of knowledge embedded in questions of competence faces the task of formalizing poorly structured concepts and fuzzy relationships. The solution of this problem constitutes the next stage of research and development of ontological approach in decision support. Thank you for your attention.